Wait, OBS is up. We have the webcam up. I think we are live. Let's just make sure I'm live streaming on my phone here, just to make sure everything's good with the sound, audio, and all that stuff. Looks pretty good. Okay, I think we can get started. All right, welcome back to another live stream. We're just gonna dive right in, not too much introduction or anything like that. Today's topic is the same one as yesterday, which is just the latter part of it. So let's see, what do we have? Yesterday was the discipline of health informatics, and we did a little bit of the fundamental informatics concepts, models, and theories. Today, we are going to, oh wait, I take that back. We're gonna do more of this too. So we're actually we're gonna finish fundamental informatics concepts, models, and theories. And then day 2, we're also supposed to do core informatics literature. So those would be the 2 topics for today. I probably need to update the title to reflect that a bit. Okay, let me see. What else was I supposed to say? I think that's it. Yeah, let's just dive right in. So yesterday we were filling in the fundamental domains and then the concepts, models, and theories. So I was doing this piece. Okay, let's see. How should we do this? I think for this piece, this section, fundamental informatics concepts, models, and theories, probably try to keep it a bit more high level. We filled it up with these foundational domains yesterday, which we pulled. But I think, a lot of this, if you scan through the outline, you'll see that later on down the road, they get into more detail. So I think what I'm going to do is just literally do something like this, where it's a very basic definition of each one of these things, and we can dive deeper into those other areas later. So let me finish those pieces. Let me see. Okay. Yeah, let's see if we can go to PubMed and just look at tools and methods, concepts, models, and theories, manipulation of data. Let's see if we can select tools and methods to manipulate data. See if there's any general review things we can use. This looks interesting. Foundation of bioinformatics. Yeah, it talks a little bit about this. This might be interesting to bring up. Let's see. Did not start. Oh, nice. They have a history of it. Protein analysis. What is this thing about again? A brief history. Let's see, 1990, high throughput. Look at today. Let's see, bioinformatician. I think what I'm going to do is cite this and actually add this to the history too. It needs Zotero to be running. Let's let that run. Try again. Yep, brief history. And I'm going to add this beginning. More copy and paste. Let me add this. I know I'm kind of jumping around to the beginning. Just want to fill in some additional details. So let's look at this one. Brief history dating back to 1970s, I think it was. Eventually this is going to be a very thorough study guide for those who are interested in reading all of this information. Go ahead and cite this. Brief history. Brief history. I think it was this one. Yep. 2019. Cool. We're going to move on down. I think they talked a little bit about big data. You know, maybe this is like too much. Let me actually go back. This is a little too detailed. Something more broad for the management of data. Just Google. Oops. This looks very like promising, but this like website is sketchy. Let's see if there's any better ones. Big data management. Oh, science white paper. This looks interesting. Data Science Foundation. How organizations create and implement data strategies. You know, things like this, variety, velocity, and volume. You know, how do you define big data? I think this would be important to know on the study guide. Big data lean. Maybe I'll just, yeah, I'm gonna cite this. And instead of tools and methods to manipulate, maybe because that's more of a, it's not really a concept per se. I think big data in itself, big data in management, I think this would be better. Big data management. Let's do that. How does this cite on the bibliography? Big data management. Yeah, there's at least a website in here, so that's perfect. Cool, cool, cool. Let's go back down here. See if there's like a nice way of, yeah, there are many ways to define. This is a really well cited article. Yeah, this is probably fine here. Like, again, trying to do just more of an introduction, so this is probably good enough. Like this, like the formatting. Maybe I just do this. And I had a website in here, huh? Reference number 7. See if there's something. Did I paste something in there already for artificial intelligence? I don't think I did, right? Where'd it go? Here it is. I did not, so let's go ahead and do that. Open the whole thing. Survey. Maybe this is perfectly fine too. We'll just go ahead and paste this in there. All right. I guess I could read a little bit about it. Big data management. There are many ways to define what big data is, and this is probably why it still remains a really difficult concept to grasp. Today, someone describes big data as data set above a certain threshold, over a terabyte. Others as data that crash conventional analytical tools like Microsoft Excel. More renowned works to identify big data as data that displays features of variety, velocity, and volume. Even though they are all partially true, there's a definition that seems to better capture this phenomenon. Big data analytics is an innovative approach that consists of different technologies and processes to extract worthy insights from low-value data that do not fit for any reason the conventional database systems. In the last few years, the academic literature on big data has grown extensively. It's possible to find specific applications of big data to almost any field of research. For example, big data applications can be found in medical health care, government projects and public goods, biology, financial markets. Another more specific example is big data have been used for energy control, anomaly detection, crime prediction, and risk management. No matter what business is considered, big data are having a strong impact on every sector. That's all makes sense. Cool. Artificial intelligence aims to mimic human cognitive functions. It is bringing a paradigm shift to healthcare powered by increasing availability of healthcare data and rapid progress of analytics techniques. We survey the current status of AI applications in healthcare and discuss its future. AI can be applied to various types of healthcare data, structured and unstructured. Popular AI techniques include machine learning methods for structured data, such as the classical support vector machine and neural network, and the modern deep learning, as well as natural language processing for unstructured data. Major disease areas that use AI tools include cancer, neurology, and cardiology. We then review in more detail the AI applications in stroke in the three major areas, such and such. These all have very basic definitions, so I mean, there's like everyone who's taking this test probably knows this kind of stuff, so we can move on. Project management as a concept. I don't really know if do we really need to know? Maybe like the software development lifecycle more so than project management. Again, we're trying to do, yeah, I think that might be more so. Beneficial software development life cycle. This is probably fine. Maybe something else. It's another. What is BMC? Read Techipedia. This is fine. Yeah, instead of project management, maybe software development lifecycle. Software development lifecycle, SDLC. Let's go ahead and cite this. Cool. Paste. Like this, software development lifecycle. There we go. Change management and control. I know there's usually like a lot of great information on this. Change management, leadership, control. Change management process. I want to find more data oriented. Let's do change management and control. Let's do something like that. Ah, here we go. Change control. Instead of following, this is actually perfect. The other one's change management. We will cite both of those. Change control and change management. Change management and control. Change control. Change management. Go. It's really annoying because I'm losing all the syntax that comes with it. Whatever. Let's do, actually, you know what? This is like a little annoying. Why don't I get rid of all this and do change management? Just cite that, change management. And I'll do change control as a separate thing. Change control. Oops, change control. Cool, let's move on and do this. Change control. Paste. Change control, there we go. All right, I think we got most of this stuff. Like, I don't think we need to go into too much more. There's probably some odd, I think there is user design and experience, which is definitely something important. Oh yeah, it's down here. Oh, we still have a couple more. All right, I mean, what is it, 17 minutes? So yeah, we got time. I need to move up. I need to move a little faster. Data privacy and security. This looks pretty good place. And blogs. I wonder if there's something that's published that can talk more about it. I'm being a little too type A right now. I just want some more reputable things. At least ones that are more pertinent to us, you know. Journal of Nuclear Medicine Technology. This doesn't really cover it though. This is useful. But this is a little too much. Huh. This is something we're looking for. Security and privacy in electronic health records. To report the results concerning security. This is probably fine. Let's take a look at this. Policy development. This is 2013, so this is probably fine. Wish there was like, yeah, this is perfect. I just need to find like a summary of this. Maybe we'll just do this, or actually, what security do features have? You know what? I'm just gonna copy their entire introduction for this. Let's go ahead and do that. Whoever uses this study guide is definitely going to study a lot. All right, let's close this. Let's go ahead and cite this. Security and privacy. Security and privacy. Perfect. Knowledge engineering and data ontologies. It's interesting they have something in there. Deep AI. Tech Target. It's like very sketchy looking websites. Maybe there's something like that. Knowledge engineering. This looks interesting. Despite increasing interest in research how to translate knowledge into practice, the accumulation in this field is slow. We suggest that be designed so to address these problems is crucially important to establish. It is knowledge translation. There's something else. Metabolic pathways. Let's see what else we got. Let me see if we can quote that. Milestones in software engineering history. Mapping review. Knowledge engineering. This looks very promising. That's 2012 though. Knowledge engineering for health, a new discipline required to bridge the ICT gap between research and healthcare. Despite a vast amount of money and research being channeled toward biomedical research, relatively little impact has been made on routine clinical practice. At the heart of this failure is the information communication technology chasm that exists between research and healthcare. A new focus on knowledge engineering for health is needed to facilitate knowledge transmission across the research healthcare gap. This discipline is required to engineer the bi-directional flow of data, processing research data knowledge to identify clinically relevant advances and delivering these to healthcare use. This is it. This is like pretty much it. Let me see. What are you proposing here? Yeah, I think this is fine. Basically how you create the framework for, in some ways, the digital environment that we are now in, making things interoperable. Did I cite this already? I think I did. I don't remember. Knowledge engineering. Okay. So let's see. Knowledge for health. I think I'm gonna cite this on its own. Knowledge engineering. Then we do data ontologies on its own. These are good concepts to be aware of, at least the basic definitions. Data ontologies. Let's do that. Or just ontology. Context modeling. Towards an ontology. Nope. Let's go back up. Oops. Ontologies and context modeling. No, this is too much. We do data ontology in healthcare. Here we go. Ontologies and big data healthcare analytics. Applications to routine clinical data. Ontologies are an important big data analytics tool. Historically, code lists were created by domain experts and map between different coding systems. Ontology allows to develop better representations of clinical concepts, data, and facilitate better data extracts from routine clinical data. Also makes the process of case identification and key outcome measures transparent. We describe a process we have operationalized in our research. We use ontologies to resolve the semantics of complex healthcare data. The use of the method is demonstrated through a pregnancy case identification method. Pregnancy data recorded in different coding systems and stored in different general practice systems, and pregnancy has its own complexities, and that not all pregnancies proceed to term. They have different lengths and involve multiple providers. This is perfect. I think these are one of the things that don't have access to. Let's see. Oh, maybe you do. Yeah, they do. Nice. Okay. Let me go ahead and cite this. Data ontologies in healthcare. Paste without formatting. Go ahead, cite. Oops. Oh man, it's at 30-minute mark. Moving too slow. Cool. Last one should be user design and experience. We'll find one more for that. Close these out. User design and experience. Let's do healthcare. Medium blog. No, I want another like cited article or something. User design and experience health. Oops. Approach. There's so much of this. This is probably fine. We'll just go with this one. Damn it, it's behind a paywall. But this is fine enough. Just the general concept of what you need to know. Cool. Go ahead and cite. User experience. Cool. All right. I think that is done for that piece. Cool. That is all done. A lot of information. If we go back up, so fundamental concepts. So that was section 2. Let me do section 3 now, which I only have 30 minutes to complete. And then, I might just come back around and beef some of these sections up. Core informatics literature, foundational literature, principal journals, lots of stuff. Foundational literature, principal journals, critical analysis of literature. What does that even mean? Like, is it a skill set? Like core use of evidence to inform practice. Like, this isn't. It's almost like a skill set. Anyways, be right back. Be right back. Cool. All right, core informatics literature. What do you want us to read about? So principal journal should be easy, but foundational literature, critical analysis of literature, like these should be obvious, right? Critical analysis of literature, use of evidence to inform practice. I think just knowing the literature itself it's self-explanatory that you use the literature to inform practice. So, all right. I think what they're trying to get at is maybe like, where should you find your primary sources of literature? Which, of course, AMIA. I wish I had the of informatics articles. Journal of Global Thing. Informatics. Amy is not on here. Informatics. I don't know if this how reputable this is. I'm pretty sure I looked at impact factors for informatics before. Let me see. Let's try this. I don't remember where to look this up. Campus. Oh, here it is. I need to look at databases. This looks more familiar. Changed everything up. I think this is it. Journal citation reports. I think this is where you look it up. Actually, I don't browse by journal. All right, AMIA Informatics. Journal of Biomedical Bioinformatics. Medical Informatics. Medical Informatics. I don't think this is the one. Where are your other journals? Journal impact factor. Informatics. Stick with this one. Categories. Medical informatics. I think that's what we're looking for. Yeah, this is the one. This is probably good. So, journals by rank. Impact factor. AMIA is the 5th one up down here. So we can probably look at these. I don't even know. I've never heard of this one. This is also another like way to look at it. This score is another great way of looking at Journal of the American Medical. Yeah, this is like always the primary one I look for. But I will use this in building out the principal journals. So, you know, something objective to look at, which is always nice. Objective way of quantifying, you know, so by journal factor. So by order of journal impact factor. I think these are by year. So I'm just gonna say 2021. This is 5 point. No, oops. IEE, Journal of Biomedical and Health Informatics, Journal of Medical Internet Research, Artificial Intelligence in Medicine, GMIRM, Health and View Health, and then Journal of the American Medical Informatics Association. So this one is 4.12. Wow, that's a lot of sites. 9,000. This is 4.33. This is 5.034. Oops, I think that was 3.13. 4.383. Number 2 is 5.034. And then this one is 5.223. So by order of Gen factor score, which is just another way of I remember learning about this like last year, and they're saying like this might, you know, it's always just look good to compare the two. And this one may also be less biased or something. I don't remember why. But it's nice because when you look at this, you can see that the AMIA meets both of these lists. So that should mean something. And then the other ones fall off. So AMIA, I mean, almost like validates that AMIA's journal article should be your primary source for this kind of stuff. Journal of the American Medical Informatics Association. 0.01741. 4 is IEE. Oh, this one's good. So this is probably another one that people should check out. It's on both of these lists. 1298. And then the fifth one is statistical methods in medical research. So 0.011, 0.01188. Perfect. Those are your principal journals. I think foundational literature, these I'm just gonna like, that's pointless. Foundational literature, maybe like key articles that you should read and stuff. There's like key books, foundational literature. I feel like AMIA had a list of references for this study guide, so I'm assuming I can probably just steal what they got and call it a day because we have 41 minutes. Certification guide. Certification guide. Where is your reference materials? That's not what I'm looking for. Certification staff, exam eligibility, AHIC application. Where did it go? I remember they had AHIC exam. Here it is. Suggested references. Yeah. You know, there should probably be another one here. The applied clinical informatics thing. Applied clinical journal. Yeah, applied clinical informatics. Others. Applied clinical informatics, which I don't really remember what the difference was, but being that it's associated with AMIA, it's always good. So there's no foundational literature per se. Foundational literature. I feel like just copying these are not the best. Oh, I'm just gonna cite this. I'm gonna say foundational literature, say suggested readings from AMIA AHIC Certification reference. So we'll do this. Oops. That's not what was this one suggested? Yeah. So do that. And then what would be some foundational literature? I feel like there's a lot, right? So to understand this, no problem. You know what? This core informatics literature. I wonder if AMIA has more. Let's go to Jamia's top read. Let's see if there's anything that would be super awesome. Most read, editor's choice. Here's a nice one. I think maybe like some more modern articles. This is probably good. Clinician burden. Yes, this is always a good one. Or make this one of them. Did it cite? Yeah. this. So it's tech. Good policy one. See some other ones. Provider burnout. Editor's choice. Scoping review. No. This is probably good too. Natural language processing. Let's go ahead and do this one. Come on. Man, it's from 2011. Thing is, you actually need to read these too. It's maybe a little specific. Maybe like something more broad. Close, close, close. Problems with health effects on healthcare. What's this about? To systematically review studies reporting problems with information technology. What does it say? Describing problems remain largely qualitative and quantitative risks. Issues. This is probably good, like just knowing the different types of problems. This is probably good. Let's go ahead and cite. Problems. Yep. Close all this. Go back. I feel like I'm cheating here, just going to the most red. This will probably be important in general. Telehealth, more modern type stuff again. Telehealth transformation. Telehealth certainly is going to play a huge role. Oops. So let's do that. Cool. Impact. Oh, I like this. I think I've read this one before. Impact of the digital divide in the age of COVID-19. Yeah, this is good. I think this is important too. As we become more digitized, what are some of the problems that we see? It's like more of like a social type article, which would be super awesome. Broadening our skill sets here. Impact of ooh, this is a very technical one, but this is probably good to know. Little applications of blockchain. I need a more broad one. These are a little too specific. Let me see if there's one I can find in general. Gives more of a comprehensive view of things. Do we have like a AMIA open? AMIA alerts. It is choice. Let's see. Let me do like an overview of health information technology or something. Let's do featured. This seems really helpful. Health and healthcare disparities continue despite clinical research and policy efforts. Large clinical data sets may not contain data relevant to healthcare disparities, and leveraging these for research may be crucial to improve health equity. Health disparities collaboration was commissioned by patient centers, blah, 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 to examine. Oh, this is specific for health equity, which is important, but I want to find something a little bit more broad. Social determinants of health, which I guess this is kind of similar to social determinants of health and the impact. Yeah, this is definitely important in the new age, so we are gonna include this one. Go ahead and do that. Social. I wish I could just like download all this information to my head. Like I want to read it, but it just is a lot of information right now. No, maybe I can do something like EHR. Maybe this is good. Like a broad overview or something. What does this talk about? This is not what I'm looking for. Let's try that again. Oh, it just went down into it. Featured. Moving towards reconsidering hospital adoption. Measurement, high tech. Characterizing. Towards clinical data. All of these are great titles. You want to like read all of these things. What is this one about? In 2009, a prominent national report stated that 9% of the U.S. has adopted a BASIC. This statistic was widely cited, became a mimetic anchor point for EHR adoption at the dawn of high tech. This calculation relies on specific treatment of data. Alternative approach may have led to different sense of U.S. hospitals. From AHA IT supplement. No, I want to do like a general review. Let me see if there's another one I can look at. EHR implementation, high tech, United States. JD. No. Not that either. Maybe this would be a better one. Yeah. Yeah, this is probably a good foundational piece to read. The journal doesn't look very reputable, but it is good enough. We just need a basic kind of overview. So this is good. Okay. I think that should do it for now. Be nice to read some of this. So core informatics literature. This is probably fine. Being able to read these kind of things. Oh, you know what? What's actually good is the artificial intelligence one. National Academy of Medicine Artificial Intelligence. Given that that is the new way through, let's see, where is it? Download. Let's go ahead and cite this. Everyone should read this. It's like 300 something pages. I got through like 200 something of it. That's not the artificial intelligence. Where's the height? There it is. Cool. I think that's gonna do it. Because next one is section 4, so I think this should be fine. You know, I was hoping to do more studying in this case, but just putting together the outline in itself is good enough. Again, when I get back to the studying, I'll probably just review some of this information. This is helpful, you know. Might end a little early today. It's 56 minutes of streaming. I finished section 3, so that was good. And so let me take a look. Yeah, so section 3. So tomorrow will be section 4, and then a bit of 5 is what we're gonna do. Yeah, that'd be day 3 in between here. Oh, actually be at 1.5 and 1.5. These 3 will be the next 2. This is gonna be a lot of work over the next 95 days. All right, cool. So we're gonna end here. That should be good. Thank you guys for tuning in. If you did, if you're watching this in the rewatch, cool.